Hi everyone, so at the end of the PowerPoint that you were working on, you were told to go through example 14.8 on page 206. So if you could open that up now and have that in front of you as we're going through it, that would be great. I'm just going to talk you through this question so that hopefully the steps will make a bit more sense, and then I'll give you a couple of questions to go through on your own. And you can let me know at any point if you have any questions on any of it. So step one in balancing a redox equation. So just a quick note actually before we start. Redox equations, what we're looking at here is reduction and oxidation. So a redox equation is anything that has one substance being reduced and one substance being oxidized. Other than that, let's get started. So step one is saying assign oxidation numbers to all of the atoms. This is done in the book for you, so you can skip ahead if you're okay with that. I'm just going to talk through it briefly just for anyone that might need another little recap. So MnO4 minus here, first of all, we know that there's a -1 charge, so when I add up the oxidation numbers of the manganese and the 4 oxygens, they're going to have to equal to -1. So our first rule that we need to follow here is that oxygen is always -2 unless it's in a hydrogen peroxide or bonded to fluorine, which in this case it's not. So oxygen is going to be -2, and we have 4 of them, so that means overall that's -8. If I want my oxidation numbers to add up to give me -1, then I need to assign manganese an oxidation number of +7. Iron, hydrogen, manganese and iron here again are all ions, so they're all going to follow the same rule. They're all going to have the oxidation number equal to the charge, so +2, +1, +2 and +3. Now you'll notice in the book they have all the charges written 2+, 3+, like that. And don't forget that when you're writing the oxidation number, the plus or minus has to come first. Then all we've left is the water over here. So I've got 2 hydrogens, and one of my rules is that hydrogen is always +1 unless it's bonded to a metal in group 1 or group 2, and oxygen is always -2, and that satisfies the rule as well that when you add up all the oxidation numbers they should equal to 0 for a molecule, which they do in this case because we've got 2 hydrogens and 1 oxygen, so that will add up to give 0. So I'm just color coding it down here in the corner for you if you want to screenshot any of it. Step 2 then is identifying the substances which have changed oxidation number. And those for us are manganese went from +7 to +2, and our iron went from +2 to +3. So our greens there are step 2. And step 3 we'll put in red. Step 3 is show the number of electrons lost and gained. So for iron, what happens to get it from +1 or +2, sorry, to +3? It lost 1 electron. That's what happened. And so oxidation is loss, so that must be oxidation, just to point that out. And secondly, manganese. If we look at manganese going from +7 to +2, that must have gained electrons, so the charges or the oxidation number is less positive. So it's gained 5 electrons, and that is of course reduction. Oxidation is loss, reduction is gain, oil rig. So that's step 3. Step 4 then is work out the ratio of oxidizing to reducing agent. So that's just looking at these numbers here. So the iron lost 1 electron and the manganese gained 5. Now, where did the manganese gain those 5 electrons from? It gained it from the iron. So what we're going to have to do here is we take the numbers 1 and 5. They're in the lowest ratio they could be, so we don't need to do a calculation there. And what we do is we take that 1 from iron and we're going to put it in front of the manganese substance. And we take this 5 down here from the manganese and we put it in front of the iron. And from there, so that's what we do. We take the numbers and we put them in front of the opposite substance. And from there, then we just need to balance the equation as we normally would have. So I'll use just this brownie colour for that. So counting them up down here, I have my box ready to go down at the bottom. I have 1 manganese on either side. I'm not going to go through this in too much detail now, but if you're having trouble with it, let me know. 4 oxygens and 1 oxygen on the right. 5 irons, on the left and 1 on the right. And then hydrogens, I have 1 on the left and I have got 1 on the right. That's a 1. 1 on the right. So the easiest thing there to manipulate first of all is going to be the iron. So all I have to do is multiply the right hand side by 5. So I will just multiply that by 5. It's not changed anything else, so that's all I need to do there. My manganese is already balanced for me. Next I'm going to, sorry, I got that wrong. That should be a 2 there for the hydrogens. There's 2 hydrogens up here. Little mistake there. So now I need to balance out my oxygens and my hydrogens. Since I know I'm going to have to multiply the right hand side for oxygen, that's also going to affect my number of hydrogens here. So I'm actually going to work with oxygen first. So I'll multiply the left hand side by 4. So I get my 4 oxygens, and that has changed my number of hydrogens to 8. So now I've got 8, and all I've left to do then to balance, and that's balanced, iron is balanced. I just need to multiply the right hand side hydrogens by 8. There we go, all balanced. So hopefully going through that in a bit more detail has given you a bit more understanding maybe. And what I'll do now is I'm going to go and assign you some questions to do based on this, and let me know, send me a quick message on Edmodo if there's any issues with it.